In this tutorial, we are going to calculate the currents for this circuit. As you can see, this circuit consists of a voltage supply, Vs, that is connected to two resistors, R1 and R2. R1 and R2 are connected in parallel in this circuit. So the total current for this circuit, I total, IT, is going to split at this junction here into two currents, I1 and I2. And that's why we call this circuit as a current divider, because the total current for this circuit is splitting between two currents. I1 is going to go right through R1 and I2 is going to go right through R2. Two currents out of total currents split. Now, in order to calculate these currents here, we have to calculate the total resistivity of this circuit, and the total resistivity is given by R total equals R1 multiplied by R2 over R1 plus R2. This gives me R1 is 680 ohms multiplied by 330 ohms over 680 plus 330 ohms. This gives me roughly 222.17 ohms. Now, having calculated the total resistivity for this circuit, we can calculate the total current for this circuit, and the total current for this circuit is given by Ohm's law. I total equals the voltage supply over the R total. Voltage supply here should be 20 volts, and I total therefore is 20 volts over 222.17, and this gives me roughly 0.09 amps. I1 can be calculated as follows. I1 equals R2 over R1 plus R2 altogether multiplied by I total, and therefore R2 is 330 over 680 ohms plus 330 altogether multiplied by 0.09, and this gives me roughly 0.029 amps. Similarly, I2 can be calculated as follows. I2 equals R1 over R1 plus R2 altogether multiplied by I total, and R1 in this situation is 680 ohms over 680 again, 680 plus 330 ohms for R2 altogether multiplied by 0.09 for I total, and this gives me roughly 0.0605 amps.